Okay, yeah, backtrack, forgot. Okay, so quadrant 2, if that's a 60-degree angle, right? Brandon said it's 30, 90, 30, we got 120, right, to the terminal side. Okay, so if I draw the 60-degree angle, the triangle, this is 60, what's this angle measure? 30. Okay, what's this side length? 2. What's this side length? Rad 3. And what's this one? Perfect. Right? Okay, so if this is 60 degrees, this is OAH. Your hypotenuse terminal side is always hypotenuse. So if we want SOHCAHTOA, right? What is sine of your 60 degrees here? What would it be? Okay, but now I have to change it. Okay, you want to say rad 3 over 2, and you're correct what I drew. However, when you guys are looking at quadrants, okay, if I plot this point, right, so this is 3, 2, you guys would say this is the coordinates 3, 2, right? 1, 2, 3, 1, 2, right? Okay, if I went 3 here, what's the number that I would write here? -3. Yeah? Okay, so if this is -3, what is that 1? Does that kind of make sense? If this is my origin, if I move to the left from my origin along the x-axis, isn't this the negative x-axis? So that would be a -1 length. Okay, but this rad 3 would still be positive because I'm still moving up the y-axis. So this rad 3 would still be positive. Yes? And then of course, this hypotenuse is still going to be positive because it's diagonal. Okay? Okay, so sine doesn't change. It's still rad 3 over 2. And so for sine of what, whoopsie, it's rad 3 over 2. But you have to understand it's 120 degrees, but you're building it off the 60-degree triangle. Okay, so now what is cosine of 60 degrees? It's A over H, and so what would you say it is? -1/2. Right, -1/2. And so this is, where am I? -1/2. And so if you typed it in, wait, can you, yeah. There's my -1/2. So for the kids that you guys filled it in like 3 minutes and you're like, oh, can I get credit for this chart? I have it done. If you're not drawing it, no bueno, because when you guys take your quiz, you do not have access to a calculator. And notice, I didn't put 120 anywhere here. I'm using the 60. So that's why you have to know how to draw the triangles. And you have to know what's negative and what's positive. Okay, so then what is tangent of 60 degrees? OA.
Rad 3 over -1.
Right, rad 3 over -1, but they're probably just going to give us negative rad 3 is what the calculator would give you, right? Because if I did, that's negative rad 3. See? Okay, so when you get over here, you can on the side if you want, you can go rad 3 over -1, but it's negative rad 3. The reason why you put that, if you wanted to, is because these are reciprocal, like inverse functions kind of these. And so if you're able to put the ratio, then you kind of know just how to flip it. So if you want to, you can, but it helps if you just kind of know where it came from. Okay, so 135 degrees. 135 degrees. All right, if I write the 45-degree angle here, right? If this is 45, this is 45, this is 90, so standard form to the terminal side, what is this angle measure? 135. And so that's why when we do SOHCAHTOA, we're going to fill it in on 135. We're going to go sine, cosine, tangent, but we're going to be writing in sine of 45, cosine of 45, and tangent of 45. Okay, but, I mean, you could still write the 130. Like, there was nothing wrong with you putting here sine of 120 degrees, cosine of 120 degrees, tangent of 120 degrees, because that's really what you were getting over here, right? That really was the terminal side to the triangle. So here, even though I'm going to take SOHCAHTOA, and even though I'm working off a 45, 45, 90-degree triangle, I'm really taking the trig of 135 degrees, right? So even though I'll write sine of 45, it is really sine of 135 degrees. It's really cosine of 135 degrees, and it's really tangent of 135 degrees. Whoopsie, sorry. Yeah? Okay.
There's a bug, there's a bug.
A big bug? It's big. It's big. Where is it? Wait, pick up the bag. Oh, it's not on the break yet. Okay, let me pause it. You can't, you don't, no? No, you don't kill it. It's just a cricket. Loki kill it. We used to have a bearded dragon, and towards the end I would just grab it with my hand, but I'm not grabbing it because it's the school and it's kind of gross. But it's gonna go jumpy. Oh, it's jumpy. Oh no, I got it. Hold on, you guys. Let's see if it pops out. I don't know if it's... Yes, I'm here. Alright, it's out, you guys. It's hot in here. Oh my gosh, you guys. It'll be really cold outside. Yeah, like you really died. It was a grasshopper and you're stuffy. You probably can't breathe in here. Okay, we still have the video going, so whoopsie. Okay. Okay, I don't like crickets at my house because what eats crickets? No, cats just like torturing stuff. But no, what eats them?
Spiders?
Yeah, spiders. Usually, yeah, crickets. Like usually there's like a black widow nearby or something. When they're in my garage, I'm always like, out, 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 because spiders. Okay. All right. So look, if you know what you're doing and maybe the conversion is throwing you off, then whoopsie, this was supposed to say cosine. Then just if you would rather write the 45, because remember 45 degrees is quadrant 1. We're in quadrant 2, so it has to be between 90 and 180. But because we're drawing the 45-degree triangle, maybe in your head you're like, no, I really need the 45 because I understand this is my angle. So this is oh, we forgot to label it. OAH. Oh, what are my legs on a 45? What are my legs on a 45? What's the length? 1, 1. And then what's my hypotenuse? Rad 2. And I have like nowhere to put it. So 1, 1, rad 2, right? Okay, so OAH. So yes, if you guys are comfortable putting in the sine of 45, it's okay. You know, you're not going to get docked when you draw it, because some kids just they just want to keep it to the 30, 60, 45. But if you understand it's really a 135-degree opening, what's the sine? What's the ratio of sine 45 or sine of 135? What would I put? Right, you would put 1 over rad 2, however, whichever one you want to write. However, you're not allowed to have a you're not allowed to have a fraction of decimal, radical, radicand as a denominator. So remember what we went over yesterday. You got to take it to the top. And so what's rad 2 times rad 2? Rad 4. This is a perfect square. What's the square root of 4? 2, and so it's rad 2 over 2. So rad 2 over 2, and then you already know cosine is going to be the same, right? Because the legs are identical, right? Okay, so what's the cosine of 45, or really, what is the cosine of 135? A over h, and so it's 1 over rad 2, but same, you're not allowed to have a radical right in the denominator's position. No, no, no. So it's really rad 2 over 2. So rad 2 over 2. And I'll stop at the, oh wait, we still have one more. Oh, but this video is going to be so long. Okay, tangent of 45. So what's OA? 1 over 1, and so, right, it would just be 1. And so here, you could put just 1, but on the side, if you want to put 1 over 1, because cosecant, well, like, we have to do worksheets first, but cosecant, secant, and cotangent is just 1 over sine, 1 over cosine, 1 over tangent. Okay, and then keep going. At this point, it's going to be like a 18-20 minute video. Okay, so then 150, right? So we did this, we did the 60, right? You did the 60, we did the 45 degrees, so now I need to do the 30-degree angle. So if I cover the 30-degree triangle, this is 30, right? Remember, this is 90, this is what? 60, and so that's why the angle measure is what? 150, right? Okay, what is the terminal side or the hypotenuse? What is that length? I'll point right now. Okay, what's this length? 2, because 30 goes into 62 times. What's this one? Yeah, because how many times does 30 go into 90? 3 times, but it gets the rad. And what's the 60-90 side? 1. Whenever you're covering the unit circle, if you really honestly draw it up, you'll forever memorize the triangle legs. Like, you have to repeat it so many times you end up memorizing it. Okay, so remember, we're doing 150 degrees. But I drew the 30-degree right triangle. So whether you write sine of 30, cosine of 30, or tangent of 30, you just have to remember it's really the 150. So if underneath you want to, whichever one you want to write, you don't have to do both. And it's the same. Okay. All right, so again, this one is negative. Oh, you guys, we redid it, but I forgot to put the 1 on the negative. You see that? Okay, look up, you guys, the cricket. Okay, see how we went back? You see the pen? This is a -1, yes? Okay, so is sine affected? No, is cosine affected? It's A over H. Sorry, I moved my finger.
No.
Yes, it'll be negative.
It would be -1 over rad 2. So this becomes negative rad 2 over 2. Because this is your negative here, negative 1 a over h, negative 1 over rad 2. So negative 1 times rad 2 is negative rad 2, and now you get negative rad 2 over 2, and so this is negative rad 2 over 2. Mark that. Okay, so now with here, this rad 3, what am I going to do to this rad 3? Make it negative. And so now here's your O, A, H, and this is your 30. Okay, so what is SOHCAHTOA? What's the ratio for sine of 150 degrees? Yes, 1/2. So it is 1/2. We're almost done, you guys. It's going to be a long video. Okay, what's cosine? AH, huh?
Negative 3 over 2, or rad 3 over 2.
Yeah, negative rad 3 over 2, and it's written beautifully, so I don't have to clean it up because the denominator is an integer. And then what is tangent? OA. One over A. Negative rad 3, but again, you cannot have a radical in the denominator's position, right? So we're going to multiply by that rad 3. So I get rad 3, and then what's rad 3 times rad 3?
Is it a negative rad 3?
No, just do the positives. We'll do it later.
Rad 9.
9, right? Just bring down the negative. And what's the square root of 9?
3.
3, and so it's negative rad 3 over 3. So how do you want to mark it on your chart? If you want to put it like that, if you want to put it in the middle, just know that there's one negative there. Okay, but I'm going to write it because it was originally on the bottom, right? If you, what am I, negative rad 3 over 3? Right? Okay, so there's your second quadrant. We'll do 3. You could try 3, you could try 4, but for those of you moving on, okay, any point here is what? A negative and a negative. So that means when you draw your triangles in quadrant 3, this is negative, and the two legs are both negative, not the hypotenuse, because this is a negative x-axis, this is a negative y-axis. And then when you're in quadrant 4, this is quadrant 3, when you are in quadrant 4, your triangle is going to have, this leg is on the positive x-axis, but this leg is moving down the y-axis, which is the negative length. So these legs are negative, negative. On quadrant 4, it's positive, negative. All right, I don't even know what time it is, you guys. You get out when? 10:00.
10:17.
Oh, okay. Okay, so let me stop this. Let's see how long it is.